Okay, so this is the review for the polynomial test. The first 5 questions want you to determine if the functions are polynomials. For those that are, state the degree. For those that are not, tell why not. For something to be a polynomial, we need to use one letter the whole way through. Any exponents must be positive and integers, meaning no fractions. And I cannot have any i's anywhere in here. So on number 1, there's one letter going all the way through, so that part's good. I have an x and an x and a power of 2, so we're good there. And there's no i's. So yes, this is a polynomial. To find the degree, it's going to be the biggest exponent after you've simplified. Because this term right here is squared, this is really an x squared. And an x squared and an x is going to give me x to the third, so this is going to have a degree of 3. Number 2, there's one letter all the way through again. My exponents are both positive, nobody's a fraction, and there are no i's. So again, yes, this is a polynomial. There's no multiplication to do this time, so I just go grab the biggest exponent, which happens to be 4. So it's a degree of 4. Number 3, again, there's only one letter, so that part's good. This exponent right here is a positive 2, so it's not a fraction, it's not negative, and there are no i's, so this is another yes, and it has a degree equal to 2, the biggest exponent. Number 4, there's one letter going all the way through, so that part's good. I have a positive exponent of 2, but what you may or may not remember is that the square root of x really means x to the 1/2. So now I'm going to write a no because you cannot have a fraction exponent. So this is a no because it's not an integer. Number 5, there's one letter going all the way through, so again, that's good. What you may not remember is anytime you have an x on the bottom, it means it was really an x to the -1. So now I have a negative exponent, which is also not okay. So this is also not a polynomial. On 6 through 9, they want you to transform an x to the 4th graph and an x to the 5th graph. So what you have to remember before you start graphing is that all x to the 4th graphs are even. So they have a point at 0, 0, a point at 1, 1, and a point at -1, 1. So anytime they ask me to do a transformation of an x to the 4th, I'm looking at these 3 points. If they ask me to do a transformation of x to the 5th, that's an odd graph. And all odd graphs go through 0, 0, 1, 1, and -1, 1. So all odd graphs will look like this, but they'll go left, right, up, down, stretch. So on number 6, because it's in parentheses, we're going to do the opposite. So it's going to go left 1. So I'm going to take this graph, and I'm going to move all 3 points left 1. And that's all you have to do. That one's done. And it'll be multiple choice. You'll need to be able to look at your graphs and know that, hey, it's even, so it needs to be a U-shape, and it went to the left. So you're looking for a U-shaped graph that went to the left. On number 7, we have a number in parentheses again, so I'm going to do the opposite. So it's going to go right 2, but this time it's an x to the 5th graph. So I'm looking for an odd graph. So I'm looking for a graph like this that goes to the right 2. So I'm looking for something like that. Number 8, I have a -3, but there's no parentheses, so this graph is just going to go down 3. It's an odd graph, so I'm looking for a picture like this that goes down 3. Make sure that you're looking for this shape and not this one. On number 9, it's an x to the 4th graph, so I'm looking for a U shape. The -1 is on the outside, so again, I'm going to do exactly what it says, and I'm going to go down 1. So I'm looking for a U-shaped graph that goes down 1. On numbers 10 and 11, it says form a polynomials whose zeros and degrees are given, write the factors and FOIL. So they want you to do both. So anytime they give you the zeros, they're really also giving you the x-intercepts. And you're going to write them in parentheses, and you write the opposite of what it has. So if it says there's a 0 at -1, it means you have a factor at x plus 1. If you have a 0 at x plus 1, it means you have a factor at x minus 1. If you have a 0 at 3, you have a factor at x minus 3. Okay, so that's one way to write it. We just wrote our factors. Then you would want to go FOIL. So if I FOILed these two first, we get x squared minus 1x plus 1x minus 1, which gives me x squared minus 1. And then I have to multiply it also by this term. I have to bring it down. And I'm going to multiply again. And that's going to give me x to the third minus 3x squared minus 1x plus 3. And that's all you have to do. So on the test, Ms. Puckett may ask us for this form or this form. You need to be able to do either. So number 11 is going to work the same way. We have a 0 at negative 3, so I have a factor at x plus 3. I have a 0 at 0, which means I have a factor of x. I like to put those out front. That's just my preference. And then we have a 0 at 4, which means I have a factor of x minus 4. Again, I'm going to go multiply these two first. So I get x squared plus 3x. And now I'm going to take this answer and bring this down, and I'm going to FOIL again. So x squared times x is x to the third. X squared times negative 4 is negative 4x squared. 3x times x is 3x squared. 3x times negative 4 is negative 12x. And I'm going to combine like terms, and we're done. And that's it. Okay. On number 12 and 13, they want to know, use the factor theorem to determine whether x minus c is a factor of f. If it is, write f in the factored form. That is, write f in the form of x minus c times the quotient. So when you get to problems like these, this is when we do synthetic division. And the rule is you simply bring down your coefficients in order of exponents. And if any exponent is missing in order, you have to put a 0. So I'm going to go check that first. X to the third, x squared, x to the first, and then I have no x's. So nothing's missing. It goes 3, 2, 1, none. So I just simply bring down my exponents, my coefficients. And I'm going to go divide all of those by 3. So synthetic division. Remember, you're going to drop the first term, and then you're going to multiply, add, multiply, add, multiply, add. If I get a 0 right here, then the answer is yes. If I do not get a 0, then the answer is no. So I bring down the 4. 4 times 3 is 12. 12 plus negative 3 is 9. 9 times 3 is 27. 27 plus negative 8 is 19. 19 times 3 is 57. 57 and 4 is 61. This is not a 0, so the answer is no. It means that 3 is not a 0, and x minus 3 is not a factor. 13 is going to work the same way, but this time we're going to notice that I'm missing some exponents. I have an x to the 6th, but I don't have an x to the 5th. So I'm going to have a 0 there. I have an x to the 4th, but I don't have an x to the 3rd. So I'm going to have a 0 there. I have an x squared, but I don't have an x to the 1st. So I'm going to bring them down in order, and for every exponent I'm missing, I'm going to put a 0. So I have 2x to the 6th, 0x to the 5th, negative 18x to the 4th, 0x to the 3rd, 1x squared, 0 x's, and then a minus 9. And then I'm going to go do my synthetic division to see if I get a 0 right here. So again, we drop the first term. We're going to multiply, and we're going to add. We're going to multiply, and we're going to add. We're going to multiply, and we're going to add. We're going to multiply, and we're going to add. We're going to multiply, and we're going to add. We're going to multiply, and we're going to add. So this time the answer is yes. And the directions said if the answer is yes, then they want you to go write it in factored form. So if negative 3 is a 0, that means x plus 3 is a factor. So this is the x minus c part. And then they want me to go write the quotient. The quotient is what's left. It's this piece right here. These are the coefficients for the degree 1 less than what I started with. So if I started with an x to the 6th, that means this is 2x to the 5th. And this is minus 6x to the 4th, 0x to the 3rd, 0x squared, plus x to the 1st, minus 3. Okay. On number 14 and 15, they just want me to list the potential zeros. And this is actually pretty easy. all you have to remember to do is go do all your factors of the last number divided by all the factors of the first number. So my last number here is 1. All my factors of 1 are plus or minus 1. My first number is 3. All my factors of 3 are plus or minus 1 and plus or minus 3. From here, I'm going to go divide. 1 divided by 1 is plus or minus 1. 1 divided by 3 is plus or minus 1/3. And that's it. I'm done. There are 4 possible answers. 1, -1, 1/3, and -1/3. We're going to do the exact same thing for number 15. We're going to list all the factors of the last number, plus or minus 1, plus or minus 2, divided by all the factors of the first number, plus or minus 1, plus or minus 3. And I'm going to divide 1 by both of these numbers, and then I'm going to divide 2 by both of these numbers. So I'll start with the 1. So 1 divided by 1 is 1. 1 divided by 3 is 1/3. Now I'm going to do the 2. 2 divided by 1 is 2. 2 divided by 3 is 2/3. So this time there are 1, 2, 3, 4. There are 8 possible answers. Positive 1, -1, positive 1/3 or -1/3, positive 2 or -2, positive 2/3 or -2/3. And these are called your possible zeros. I don't know if they work. I just know these are things I could try. On 16, 17, and 18, they want me to actually go find the zeros. And they gave me some choices so that I don't have to start from scratch. So we're going to go do the synthetic division just like we did on numbers 12 and 13. And if I get a 0, it means it's an answer. So an x to the third is going to have 3 answers. And I need to pick one of these to go try. I'm going to try the very first one that she asked me to try. So I'm going to go try -3. I'm going to bring down my coefficients 1, 2, -5, and -6. And there are no exponents missing, so I don't need any zeros. So I bring down the first term. 1 times -3 is -3. I'm going to add those and I get -1. I'm going to multiply those and I get 3. I'm going to add those and get -2. I'm going to multiply those and get 6, and I get a 0. Because I get a 0, it means this is one of my answers. So one of my answers is -3. From here, I'm left with a 1x squared minus x minus 2. Because remember, it's always 1 less. Because I'm left with a squared, I'm going to go use my quadratic formula to find the other 2 answers to make my life a lot easier. This is supposed to be a negative. Okay, so x equals the opposite of b, so 1 plus or minus the square root of, so b squared, -1 squared is 1, minus 4 times a times c. Well, a is 1. 1 times -2 is -2. And then I've got times 4 would be a negative. So a negative is going to give me a positive 8. So so I have minus, and I have 4 times 1 times -2 is -8. And 1 minus a -8 is 1 plus 8. And then 2 times 1 is 2. So this, if I add these together, I get 9, and the square root of 9 is 3. So I have 1 plus 3 divided by 2, and then I have 1 minus 3 divided by 2. 1 plus 3 is 4, divided by 2 is 2, so there's another answer. 1 minus 3 is -2, divided by 2 is -1. So there's my next answer. We're going to do the exact same thing here. It doesn't change. So I'm going to go try an answer. I'm going to go try 3. Oh wait, I need to have 3 answers. Sorry, I forgot to write that up there. So I'm going to go try 3. And I have a 1, a -8, a 17, and a -6. 3, 2, 1, none. Nobody's missing. So I bring down the 1. That gives me 3. That gives me -5. That gives me -15. That gives me 2. That gives me 6. And that gives me 0. So 3 works. I'm going to do the same thing I did here. I have a 1x squared minus 5x plus 2, and I'm going to go plug into my formula again. So x equals the opposite of b plus or minus the square root of -5 squared is 25 minus, so 1 times 2 is 2 times 4 is 8, all divided by 2 times a, which is 2. 25 take away 8 is 17. So this time it's not a perfect square. So I'm going to have 5 plus the square root of 17 divided by 2, and then my next answer is going to be 5 minus the square root of 17 divided by 2. And you just leave it just like that. So those are my answers. We don't have a calculator right now, so I'm not going to go ask you to get me a decimal, so we don't have a calculator. Okay? And you're going to do the same thing for 18. So I'm going to bring down my 1, because I'm going to try 1 first. I'm going to have 1, 1, negative 3, negative 1, and 2. Okay, and that's going to be 1, and 1 times 1 is 2. Is 1, and I'm going to add and get 2. 2 times 1 is 2. I'm going to add them and get negative 1. I'm going to add them and get negative 1 again. I get negative 2, then I get negative 2, and I get 0. So this time we're going to get 4 answers, because my biggest exponent is a 4, and one of them is going to be a 1, because it worked. This is not a quadratic, so I can't go do the formula right now. But if you remember, give me a cubed, because we started with a 4. We learned a long time ago something called factor by grouping. So you could go factor by grouping, or you could just go try another number using these coefficients. So I've got 1, 2, negative 1, negative 2, and I'm simply going to go try another number. This time I'm going to go try negative 1 and see if it works. So 1 times negative 1 is negative 1, 2 plus negative 1 is 1, negative 1 again, get negative 2, positive 2, and I get a 0. So yes, it works. Now I'm left with x squared plus x minus 2. Now I can go do my formula. So x equals negative 1 plus or minus the square root of 1, because b squared is 1, minus 4 times negative 2 is negative 8, times 1, so it's going to change to a positive again, all divided by 2. 1 plus 8 is 9. The square root of 9 is 3. So we're going to have negative 1 plus 3, and we're going to have negative 1 minus 3 divided by 2. Negative 3 plus 1 is 2, and 2 divided by 2 is 1. So this time 1 happened again. Negative 1 minus 3 is negative 4, divided by 2 is negative 2. So my 4 answers are 1, negative 1, 1, and negative 2. On 19 and 20, it's asking me to find the remaining zeros. So we're going to remember our conjugate pair theorem that says if you have an a plus bi, you're also going to have an a minus bi. Because it's a degree 3, I know I'm supposed to have 3 answers. So one of my answers is 3. Another answer is 4 minus I. The one that's missing is 4 plus I. And you're done. This is a degree 4, so I need 4 answers. I have I, 1 plus I. The pair to I is negative I, and the pair to 1 plus I is 1 minus I. 1, 2, 3, 4. They're all there. 21 through 24 is asking me to do inequalities. So to solve an inequality, the first thing we're going to do is we're going to factor if we need to, and then we're going to solve our factors. So if I were to solve this one, it would be x equals 3, and this one would be x equals 2. And those two numbers go on my number line. Because there's not a line right here, they're both going to have open circles. From there, I'm going to pick a point, our number over here. I'm going to pick a point in the middle, and I'm going to pick a point to the right, and I'm going to go plug them in right here. And if they give me a number less than 0, which means a negative, I'm going to go shade. If I don't get a negative, then I don't shade. So if I go plug in 1, 1 take away 3 is a negative, 1 minus 2 is a negative, and a negative times a negative is a positive, so I'm not going to shade. If I go plug in 2.5, 2.5 minus 3 is a negative, 2.5 minus 2 is a positive, and a negative times a positive is a negative, so I'm going to shade in here. If I go plug in 4, 4 minus 3 is a positive, 4 minus 2 is a positive, and a positive times a positive is a positive. So the only part of this graph that gave me something that was true were the numbers between 2 and 3. Same thing here. It's already factored for me. So x equals negative 1 and x equals 4. Those numbers go on my number line. This time I'm going to have closed circles because there's a line right there. and they want numbers greater than 0, so I'm looking for positive answers. So again, I'm going to pick a number over here, I'm going to pick a number in the middle, and I'm going to pick a number to the right. So if I pick negative 2 plus 1 is a negative, negative 2 minus 4 is a negative, and a negative times a negative is a positive. So I want that part. If I go plug in 0, I get a positive 1 and a negative 4. A positive times a negative is a negative, no shade. If I go plug in 5, 5 plus 1 is a positive, 5 minus 4 is a positive, and a positive times a positive is a positive. So I want everything to the left of negative 1, including negative 1, or everything to the right of 4, including 4. Now the only difference with 23 and 24 is you have to solve the top and the bottom separately. So on the top, you have x minus 1 equals 0, so x equals 1, so that goes on my number line. Open circle. The next thing you're going to do is decide what the denominator cannot be. You can never divide by a 0, so the denominator cannot be negative 3. And then we're going to do the exact same thing. I'm going to pick a number to the left, I'm going to pick a number in the middle, I'm going to pick a number to the right, any number you want, and they need to be greater than 0. So my answers need to be positives. So if I pick a number over here, if I pick negative 4, a negative minus a negative is going to give me a negative plus 3 is going to give me a negative, and a negative divided by a negative will give me a positive. If I go plug in 0, I end up having negative 1 over 3, which is a negative, so no shade. If I go plug in 4, 4 minus 1 is a positive, 4 plus 3 is a positive, and a positive over a positive is a positive. So my answers are everything to the left of negative 3, but not including it, or everything to the right of 1, but not including it. You're going to do the exact same thing with this one. So x minus 5, solve the top, equals 0. So x equals 5. So 5 goes on my number line, open circle. I can never let the denominator equal 0, so x can never equal negative 8. I'm going to pick a number over here to the left, I'm going to pick a number in the middle, and I'm going to pick a number to the right. When you go plug in, you find out the only thing I want this time are negatives, numbers less than 0. The only part that gives me a number that's negative is the middle, so my answer is going to be the numbers between negative 8 and 5, not including either endpoint. Okay, I'm going to pause the video right here and make a second video for the back piece.